Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 1. In the last two videos, we have already discussed from question 1 to question 13. And today's lesson, we will start from question number 14 and we will try to cover all remaining questions from this paper. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 14 says a student exercises by lifting weights attached to a machine. The machine has a cable as shown in the photograph. The cable passes through a handle and is connected to a weight. There is tension capital T in the cable. The angle between the two sides of the cable is 60 degrees as shown in the diagram. Part A says a person keeps the cable stationary by applying a force of 121 newtons. Determine the magnitude of the tension in the cable using a scaled vector diagram. So in this case, tension in the cable is this way. So this one is the tension. So here is also tension in the cable and person has to pull in this direction. So person is applying force along this direction. So we can simply, rough idea is that force is in this direction. Now if you look at this diagram, it is given to us that the angle between tension is equal to 60 degrees. We can redraw this one. We can redraw, let's say we have one vector here, this is T. We can label this one is T. And we have another vector, this is also T. It is given to us the angle between these two vectors. This angle is 60 degrees. 60 degrees. We can complete this parallelogram and we can try to find out the angle between this vector, the head of this vector and the tail of this vector. We can do this one by two different methods. One is the parallelogram we can use. So in this case I can take this vector, I can place here this vector, and the second vector we can draw from here. So this one is our second vector, and also we can draw a dotted line here. So this is the dotted line. So this angle we have, this one was 60 degrees. So what is this angle? I hope you will simply say this angle is 120 degrees. So the angle between the head of first vector and the tail of the second vector is 120 degrees. So this is one way you can find the angle. Now let me explain you the second way. The second way is we can simply draw one vector here. So this is our one vector and the second vector we have, that one is here, and angle between these two vectors is given. Very important point, basic concept, but I'm quite confident most of you struggle with this concept. So this angle is given to us, this is 60 degrees. So this is T and this one is T. Now a beautiful way is I can take this vector, I can just move this one in backward direction. I can take this vector simply, actually it's very hard to select this one. I can simply imagine, you can just imagine I can take a different color. I can draw here. So this is our vector. Now I take this vector in backward direction. I move this one in backward direction. So means I move this vector to this place. Now if I ask you what is this angle, I hope you will say this is 120 degrees. So this is the first thing you need to understand, is a basic concept. If you are struggling with this one, you can follow any one method to find the angle between head of first vector and the tail of next vector. So now we have the angle between head of first vector and tail of second vector. So this angle is 120 degrees. Now for this question, it is given to us that force is 121. Now the force you need to understand, the force. So the resultant, as this is in equilibrium, it is stationary. It is given to us, this is stationary. It simply means that the resultant of these two vectors, we can draw the resultant using red color, means the resultant of these two vectors is this one. So the force has to be in the opposite direction to balance this. So the force has to be along this direction. and this force is 121 newtons. So it means the resultant of these two vectors is also 121 newtons. So we have to draw scaled vector diagram. So this is over one vector, this is over another vector. So this vector, it means you can just move here. So resultant has to be 0. So this one you will move here. So that will be the final answer. Means the final shape has to be like this. You have t here, and the other vector, this one is t, this one is here, and the force has to be in this direction. So this is how we need to sketch. I hope now you have the idea about this one. So this angle we have found, this angle is 120 degrees. If this angle is 120 and these two sides are the same, so it means this angle has to be 30 degrees and this also has to be 30 degrees, because the sum of interior angles of a triangle is equal to 180 degrees. So this angle is 30 degrees, this angle is 30 degrees. We have these two vectors, they have the same magnitude, and we have the magnitude of this force. Until now we have concepts, we need to answer this question. Let's use this understanding and try to answer the question. So the first thing we need to do is we need scale first of all. So we have f, in this case f is equal to 121. So we can simply say 20 newtons is representing 1 centimeter. 20 Newton is representing 1 centimeter. So this force we have 121. So this is roughly 6 centimeters. So we can say this is roughly 6 centimeters. About, if you want to be very precise and accurate, you can use the exact number, but if you use 6 centimeters, that will be acceptable. So it means that this vector has to be 6 centimeters long and it should make angle of 30 degrees with horizontal. So now we need to draw angle. So let me try and explain you how you can draw the angle. So I'll grab this protractor. This is protractor. So we can grab this one. So let me clear everything at the background. We need to draw angle of 30 degrees. Angle of 30 degrees. So first of all we can start with this. So this is our angle of 30 degrees. So we can place this one here. So we have more space. So this one here. So this angle is 30 degrees with horizontal. So we can draw a line here. So I'll simply sketch a line here. So we need to sketch line here. So this line is at angle of 30 degrees. So this is how you can sketch the line. We can sketch the line and I can just place this one here. This line has to be 6 centimeters long. 6 centimeters long. So I will draw another line here about 6 centimeters long. So this has to be 6 centimeters long. So this is about 6 centimeters. And we don't need this line, the previous one. I can clear this. So this is at angle of 30 degrees. And the length of this one, we can also write down the length of this, because I just want to explain you in a better way so you understand one in a nicer way. So this one is 6 centimeters long. Now we need to draw T, tension. So for T, actually we need to calculate value of T. We have already discussed that we have this triangle. So this is our previous triangle. We have said this angle is 120 degrees, this angle is 30 degrees, this angle is 30 degrees, and the force is 121 Newton. So now we need to find out value of T. So value of T we can find out using cosine law. So we can simply use cosine law. So we can use between these two sides, I mean this side and this side. So we can say in this case T square will be equal to 121 square plus T square minus 2 times 121 times t times cosine of angle between these two sides, that is 30 degrees. So from here you can see this t square, this will be cancelled with this one. So if you solve for t, you will get, in this case, value of t will be equal to 69.85 newtons. Based on our scale, we have around 70 newtons. This one has to be equal to 3.5 centimeters. 3.5 centimeters. Now we can draw a line. We can draw a line from here that has to be 3.5 centimeters. Let me use different color. So we can draw the line that has to be 3.5 centimeters. The line actually has to start from this point. So this has to be 3.5. So this is 3.5. And from here again it has to be 3.5 because these two lines, they have the same length, because they have the same magnitude value of t. So this is how you need to draw the triangle. Now we can label. So this angle is 30 degrees. This angle we have mentioned, this was 120 degrees, and this angle also has to be 30 degrees. So vector, so you have to draw these arrows. So this is value of t. T is equal to, in this case, 69.85, mean this is about 70 newtons, and this is also about 70 newtons. So this is the final, and this arrow is very important, this arrow. So this is in the opposite direction of resultant of t's. So this is how you need to sketch. You also need to add arrow here. We have discussed this one in detail. I hope this one is clear to you. A nice question. If you can master this question, a lot of questions about vector diagram you can answer by yourself. And I'm hoping this one is clear to you. You can see this angle is about 60 degrees. I mean, this angle is about 60 degrees. So this angle is 120 degrees. So this is 120. So this is how you can answer. I hope this is clear to you. Part B says the cable is attached to a 150 newtons weight. Each time the person pulls the handle, weight moves up a vertical distance of 0.25 meters. The weight returns to its original position when the handle is released. The person exercises by pulling and releasing the handle. They do this 90 times in 120 seconds. The exercise machine displays the average power of the person as 35 watts. Deduce whether the power displayed by the machine is consistent with this data. So data in this case is given to us. So simply we can imagine, first of all, this one is the weight. So you can simply imagine this one is the weight. This is 150 newtons, and person lift this weight. So we can also draw here. The person lift this weight. So this distance we have lift by vertical distance, that is equal to 0.25 meters. Lift by vertical distance of 0.25 meters. And then person release the handle, weight come back. Then person again lift this one. Then release the handle, it come back. Then lift this one. And person repeat this one 90 times in 120 seconds. So in this case we can find out, first of all, the work done. So the work done will be equal to force. The person is moving with constant speed. So this is the assumption. Person is lifting this weight with constant speed. So constant speed, it simply means that the force on this one, the force applied upward, this force is also 150 newtons. So 150 newtons on the weight is up, and the weight is acting down. Weight is 150 newtons. So work done will be equal to force time displacement in direction of force. So the work done by person is equal to force applied by person time the displacement in direction of force applied by person. So we have force applied by person, that is 150 newtons, and displacement is 0.25. So we can solve this one. We will get 37.5 newtons. So this is one time is the work done by the person. We need to calculate power. So power will be equal to the total work done by the person. So we can say W total work done by person divided by total time taken. So this is the T total. Total work done. In one time the person do work equal to 37.5 joules. So this is joules, is work done. So this is 37.5 joules. And person repeat this one for 90 times, so we have to multiply by 90, and this is done in 120 seconds. So if we solve this one, we will get 28.1 watts. As in this case, 28.1 watt, this is less than 35 watts. So it means that it is not consistent with the machine data. So we can say it is not consistent with machine data. So this is how you need to answer. So if you write down these steps for this question, you will get theory marks. A nice question. There are some important concepts you need to understand. Work done is the product of the force and displacement in direction of force. So this is how we can answer. Question 15 says the photograph shows a ladder that a person can use to climb into the roof space of a building. When not in use, the ladder is stored in the roof space and the opening to the roof space is covered by a board. The board is hinged to the ceiling at one end. It is also given to us the ladder is attached to the board by a rail as shown below. A small block prevents the board from rotating into the roof space. For part A, state what is meant by the center of gravity of an object. Center of gravity of an object is a very important point, and it's an imaginary point where if we apply one single force, we can balance the object. So if we look at this marker, and if I need to find the center of gravity of this one, I will place my finger under this one and I will move. At one point, if I just apply the single force, I can balance this one. And that point where I'm applying force with the help of my finger in upward direction, that point is center of gravity. That point is where whole weight of the body may be considered to act. We can consider at single point at center of gravity, means at that imaginary single point whole weight of the body is acting. So that's the reason if we just apply single force, we can balance this one. And in the exam, if they ask you to explain or they ask you to state what is meant by center of mass, simply you need to say a point where whole mass of the body may be considered to act. When the object is horizontal, center of gravity and center of mass almost the same. They lie at the same point. But when object is vertical, center of mass and center of gravity will be different. So center of mass and center of gravity, they are very similar. So for this question, we need to define center of gravity. Center of gravity, this is how you can define, this is how you can write down the answer. In your final exam, you can simply say it is an imaginary point at which whole weight of the body may be considered to act. In the exam, if they ask you what is center of mass, we can simply then replace the weight with mass. So this is how you can also define center of mass. Center of mass and center of gravity, they play very important role in design. When we design something, these 2 points are very important to consider. So we need to consider the center of mass of the object when we design any structure. Part B says the weight of the board and rail is 50 newtons. The weight acts at a distance of 0.45 meters from the hinge as shown in the figure. The total length of the ladder is 2.70 meters with 0.85 meters to the left of the hinge. The weight of the ladder is 54 newtons. Assume the ladder is uniform. Explain why the board and ladder remain in the position shown in the figure. Why they remain in equilibrium. So for this question, we need to understand hinge is here. So this is the hinge, this is over pivot point. In a simple language, we can say this is the pivot. So there is moment due to this force, 50 Newton force, and 50 Newton force is the weight of board and the rail. So there is moment due to this force, and this ladder is uniform. means the center of gravity, so simply we can say the center of mass of the ladder is at its geometric midpoint. You can say geometric midpoint. So this is meaning of uniform. Geometric midpoint means at the midpoint, so midpoint will be somewhere here. So in this case, simply we need to find the moment. So if we draw the arrow here, so there is moment due to the weight of the ladder, so we can draw here, and this distance we need to find out, distance between center of mass of the ladder and between the pivot, and this distance will be equal to, let's say this distance is x, so x will be equal to 2.70 divided by 2 minus this distance. So this is 0.85, means 2.70 divided by 2 means we got this midpoint. Now we need to find this distance. So 2.70 by 2 is the distance from this point to the midpoint. Now we need to find out x, so we have to subtract this one. So if we subtract this one, we will get 0.50 meters. So means x is equal to 0.50. So moment due to this force, this is counterclockwise, moment due to the ladder, this is clockwise. So this is clockwise, this is counterclockwise. So we can calculate clockwise moment first of all. Clockwise moment, that is due to ladder. So clockwise moment in this case will be equal to weight of the ladder, that is 54. So we have 54 newtons multiplied by distance, that is 0.5. So we will simply get 27.0 newtons meter, and this one is clockwise moment. Due to this is anti-clockwise moment, so we can say anti-clockwise moment. So we can write on here, we have anti-clockwise moment. So anti-clockwise moment, this will be equal to the force 50 newtons, and the distance between these two is 0.45, mean the distance from the pivot, and if we multiply this one, we will get that is 22.5 newtons meter, and this one is counterclockwise. For this question, it is given to us this ladder remain in the position. It means this one is stationary. You can also say this is in equilibrium. It means clockwise moment has to be equal to counterclockwise moment. Clockwise moment we have that is 27.0 newton meters, and the counterclockwise moment we have that is 22.5 newtons meter, and this one is less. It means some moment is due to the board. So we have the board here, this one is the board, so there is a force by the board, so we can say there is also moment due to the block. So this moment is due to block. So in this case, simply we will say the block causes moment, or we can say block exerted force causes moment. So that's reason. Ladder is in equilibrium. So we can say ladder is in equilibrium, or we can say it remains in its position. Ladder is in equilibrium. So this is how we can answer these points. You need to understand. Simply you need to calculate the net moment, as there is some net moment but this is in equilibrium. It means that missing moment has to be provided by the block, because net moment in this case is clockwise, so the block has to exert counterclockwise moment to balance the net moment. So this is how we can approach this question. Part 2 says a downward force is required to rotate the board away from the block. This force is applied 0.80 meters from the hinge. Determine the magnitude of this force. In the last part we have already discussed net moment is balanced by block. Now simply we need to calculate value of that resultant, or we can say that net moment, and that moment is provided by the block. So simply we can say resultant moment. Resultant moment will be equal to 27.0, this is clockwise moment, minus counterclockwise moment, that was 22.5 newtons. So this is counterclockwise. So in this case, resultant moment we will get that will be equal to 4.5 newton meters, and this moment is clockwise. To balance this one, we can say the moment by the block, moment due to block, that moment has to be equal to 4.5 newtons meter, but this one has to be counterclockwise moment. Now we have value of the moment, so we have moment that is equal to 4.5 newtons meter, and the distance from the hinge is given, that is 0.80 meters. So we need to find out the force, magnitude of the force. So from here we can simply say force will be equal to 4.5 divided by 0.80 meters. If we solve this one, we will get 5.63 newtons. So simply here is a force, this force is here, and this one is the hinge, the distance we have. We need to find out the force, moment due to force we also have. So simply we can use this one and we can find the value of the force. This question has 2 marks. So if you have used this formula, means moment is equal to Fx, this one you will get 1 mark, and if you have got the right answer you will get 2 marks. Question 16 says a steel object is held by an electromagnet. The magnetic force prevents the steel object falling. For part A, state 2 reasons why weight of the object and the force from the electromagnet are not a Newton third law pair forces. So first of all, we need to understand a little bit about Newton third law pair. Newton third law pair, because your concept first of all has to be clear. So the first thing, Newton third law pair, they should have the same magnitude of force, same magnitude. The pair forces, they should have the same magnitude and opposite direction. So they should have opposite direction, and there should be 2 forces of the same type. Very important. Student mostly simply remember this one, same magnitude, opposite direction, but that is not the whole story. Also, forces must be of the same type, and they should be acting on 2 different objects. Acting on 2 different objects, mean not acting on the same object, acting on different objects. And also these forces act for the same time. So these are the things you need to understand for Newton third law pair forces. They should have these characteristics, or we can say these are conditions for 2 forces to form Newton third law pair. Now if you look at the given forces, in this case we have 2 forces. It is given to us this steel, this ball bearing, this one is not falling. So we have 2 forces acting on this one. So we can say one force is the weight of this that is acting down. So this is mg, this is force due to gravity, and there is magnetic force on this one that is acting upwards. So we can say this one is Fb. This is the magnetic force, and these 2 forces, they are equal in magnitude and opposite in direction. So it means this condition, these 2 conditions are satisfied. But these 2 forces, they are not of the same type, so this condition is not satisfied. Need to act on 2 different objects. They are acting on the same object, so it means this condition is also not satisfied. So these 2 forces, they do not form Newton third law pair, because they are different type of forces and they are acting on the same object. So that's all what you need to understand. So now let me show you the answer. So simply this is how you can write down your answer. You can say act on the same object and they are different type of forces. This question has 2 marks, so if you write on these 2 points you will get 2 marks. I hope these videos are helping you. If this video is helpful, or the videos you have watched on the channel, please like and subscribe, and also leave some comments in comment section, because your encouragement is very important. If you need more help and also you wanna support the channel, you can join Patreon. Part B says the electromagnet is suspended from a support by a steel cable as shown in the figure. When the object is suspended, the strain in the cable is 3.0 times 10 to minus 4. Calculate the Young's modulus of the steel in the cable. Cross-sectional area of the cable is given to us. Unstretched length of the cable is given and stiffness of the cable is given to us. So simply we need to calculate Young's modulus. This question is a little bit tricky one. So how we can start this? So we can write down first of all formula for Young's modulus. Young's modulus is equal to stress over strain, mean the ratio between these two quantities, and stress is force over cross-sectional area and strain is delta L by L, or we can say delta X by X. So I'll be using here delta L by L. So if we rearrange this one, so we will get this is F L divided by A times delta L. For this question we have value of A, so this is value of A we have here. We have value of L, so this is value of L, but we don't have value of delta L, but we have the value of strain. So first of all we can calculate delta L. Delta L will be equal to strain times the original length L naught. So this is L naught original. Now we have value of strain that is given here, so we can say this is 3.0 times 10 to minus 4 multiplied by L naught, that is 3.8. so we will get 1.14 times 10 to minus 3 meters. So this is value of delta L. Now we have value of delta L, we have value of A, we have value of L naught. So we need to find out value of F. But we have stiffness constant, means we have K, that is equal to F divided by delta L. So we need to find out F. From here we can say F will be equal to K times delta L. So we have K, stiffness constant, that is 2.8 times 10 to 7 newtons per meter, and value of delta L we have just calculated, that is 1.14 times 10 to minus 3 meters. So if we solve this one, we will get force is equal to 3.19 times 10 to 4 newtons. So this is value of force. Now we have all the quantities. Now simply we need to plug in and we can find the value of Young's modulus. So finally we can say Young's modulus is equal to F L naught divided by A times delta L. So value of force we have, that is 3.19 times 10 to 4. Value of L naught we have, so this is over L naught, so and this is 3.8. we have value of A, cross sectional area, that is 5.1 times 10 to minus 4, and we have value of delta L, that is 1.14 times 10 to minus 3. Now if we solve this one, we will get value of Young's modulus is 2.09 times 10 to 11 pascals. So it is very important to remember that Young's modulus order of magnitude is about 10 to 11. Young's modulus of steel is about 10 to 11 pascals. So next time if you do calculation, you got very small answer or you got very big answer, so it means that is not right. So it's very important to remember value of Young's modulus for steel. It is in the range of 10 to 11, means order of magnitude is 10 to 11 pascals. So this is how you can answer. If you have done these steps for this question, you will get 4 marks. This question is not difficult, just a little bit tricky. You need to understand how to play with these equations. I mean how to get value of F, how to get value of delta L. So that is only tricky part. We have value of L naught is given. So for this question, only tricky part is you need to get value of F and value of delta L. So we have the stiffness constant, so this is stiffness. We have delta L we can find because we have strain, we have L naught. Second part says the force extension graph for the steel cable is shown below. When the electromagnet is switched off, the steel object falls. A student states that the change in elastic strain energy stored in the cable will be transferred to the gravitational potential energy of the electromagnet. Discuss the student's statement. You should add to the force extension graph as part of your discussion. So, very conceptual question and also a beautiful question. Let's try to answer this one step by step. First of all, let's try to understand the statement of the student. Student is simply saying when this steel object falls, the magnet, so we can draw this one is the magnet. This magnet will move up. So we can also extend the line here. So this is the line here, and this magnet moves up. So we can, for simplicity, we can say this is the change in height. So this is the change in height. We can say this is delta H. So in this case, can we say that the change in gravitational potential energy, mean the gain in gravitational potential energy, that one will be equal to the mass of this electromagnet times G times delta H. And the student is saying is that loss in EPE is saying simply that loss in elastic potential energy is equal to delta GPE, or we can say is saying gain in GPE. Gain in GPE. So this is what student is saying. Now we need to discuss, is the statement of the student, is it valid or not? Mean, is it correct or not correct? So first of all, we can draw the line here. What this area under this line is representing, we can say this area is representing elastic potential energy, and this is the initial elastic potential energy, initial EPE. This whole area is representing initial EPE. Now it is given to us this steel object falls. When the steel object falls, then only weight of electromagnet is acting downwards, so that is equal to the tension in the string. So we can take any point here. So let's say at this point. So this is representing weight of electromagnet. So we can say now we have only weight of electromagnet. So this is weight of electromagnet, weight of electromagnet. We can also draw the line here. So we can draw one dotted line here. Now in this case, area under this one, this is representing the final EPE. So this is representing final EPE. So this is, this area is final elastic potential energy. So the change is equal to this one. So change is equal to this area. Let me use pink color, or let me use orange color. So this area is change in EPE. So simply we can use orange color. So this area, this is change in EP. Orange color, this is representing change in EP. So this is delta EPE, change in EPE. Now we need to find out what is the change. So let me draw here. So the loss in EPE, in this case we have, this is the loss in EPE. So we can also clear this one so it looks more real. So this is the change in EP. So this is change in EPE. We can also divide this one into two parts. We can draw this line here, this line here. Now in this case, what is the change in GP? Means the gain in GP. Gain in GPE is equal to the weight of this one times the height, times the height. So it simply means that is equal to decrease in extension. So decrease in extension in this case, this is equal to delta H. So this one is the delta H. So force is constant, we have delta H, so it means this area now we can use a different color, maybe we can use black color. So this area is change in GPE, means the gain in GPE is this area. So this is gain in GPE. So in this case simply we can draw here. So gain in GPE, we have this one. So this is gain in GPE, gain in GPE. So this one is gain in GPE. You can label this one on the graph. So this one we can say change in EPE. So you can also write down this one on the graph. So this is change in EPE. In this case we can simply see that delta EPE, this one is greater than delta GPE. So it means that the statement of student is not correct. So this is what you need to write down for the answer of this question. I hope this makes sense to you. Now I will simply clear this one, and I will let me use different colors simply on the top of this. So this one we can say this is delta GPE. You can simply label this one. This is delta GPE, and this total is delta EPE, and this area is initial EPE, and this area is final EPE. So these are the points you need to understand. Very nice question. If you don't understand one time, stop the video, give some time, try to picture in your mind, and then watch the video again. It will make sense to you. Now let me show you the answer, how you can write down your final answer. So this is how you can write on your final answer. You can also see this figure is here actually. Also these things are written on this one. You can also check this one, but I have explained you this in detail. So these are the points we have to mention in our final answer. You can simply say area under graph, it's elastic strain energy. As we discussed, this total area, this is the initial elastic potential energy. As weight of electromagnet is still exerted on the cable after object, so change in elastic potential energy is equal to area under graph between total weight and weight of electromagnet only. So this area means this one, this is equal to the change in EPE we have already discussed. And change in GP of electromagnet is weight of electromagnet time change in extension as we discuss here. So change in here. So the change in elastic strain energy is greater than change in GPE of the electromagnet. So we have discussed that point here. A beautiful question. Watch this one more than one time. It will make very clear sense to you. And also, if this is helpful, please like and subscribe, and also leave some comments in comment section. And also, if you need more help and you want to support this channel, join Patreon, and the link for Patreon you can find in the description of this video. Question 17 part A says, state what is meant by upthrust. Upthrust simply we can understand with the help of this container. Imagine that we have this container, and inside this container we have a fluid. I mean, it can be gas, it can be liquid. And if we place a ball inside this fluid, this ball will experience an upward force. So there will be an upward force on this ball. Then that upward force we call is upthrust, and that is due to displacement of the fluid. So this is how simply we can state upthrust. Let me show you the answer, how you can write down your answer. In your answer you can mention this point and you will get 1 mark. So simply you can say an upward force caused by the displacement of fluid by an object, and if you have written this one you will get 1 mark. Part B1 says, when the balloon is released, the initial upward acceleration is 4.80 meters per second. Show that the weight of the balloon and equipment is 13 newtons. volume of balloon and equipment is given to us, and density of air at ground level is also given to us. It is given to us this accelerate in upward direction. So first of all, we can draw free body diagram. The force acting downward direction is the weight of equipment and balloon, and there is upward force acting in upward direction. We can use letter U for this one. It is given to us, it is accelerating in upward direction, so we can say this is direction of acceleration, and direction of net force always in direction of acceleration, mean direction of acceleration and resultant force always in same direction. Now simply we can use Newton's second law equation. F net is equal to ma. F net is equal to ma. So we can say ma, this has to be equal to the up thrust. We can say here we have up thrust minus weight. So we can write down minus weight. So this is the net force. So we can write down ma. This is density of the fluid times volume of fluid displaced times g minus mg. So we can rearrange this one. We can write down ma plus mg. This will be equal to density of fluid times volume of fluid displaced times g. From here we can find out value of m first of all. So we can take m common, and so we have a plus g. This is equal to rho vg. So this is density of fluid, this is volume of fluid displaced. Now from here we can write down here. So we can say m will be equal to rho vg. So this is density of fluid, volume of fluid divided by a plus g. Now we can plug in values. Density of fluid is 1.23 and volume of fluid displaced is equal to 1.63, and times g we have 9.81, and this is divided by a, that is equal to 4.80 plus 9.81. Now if we simplify this one, we can find the value of the mass. Value of the mass is 1.346 kgs. We need to find out weight. So we need to find out value of weight. So the W simply will be equal to m times g. So we have m 1.346 kgs multiplied by 9.81. So we will get, this is 13.20 newtons. So up to 2sf, this is equal to 13 newtons. Up to 2sf, this is equal to 13 newtons. So this is how we can answer this question. So the better way is, first of all, write down in a proper form. So get expression for the mass, then plug in values, and then you can calculate weight. Second part says the graph shows how the density of air decreases with height above the ground. The scientists want to make measurements at a height of 25 kilometers where the balloon would stop rising. The balloon will expand as it rises and will burst if its volume exceeds 50 cubic meters. Deduce whether the balloon could support the equipment at a height of 25 kilometers without bursting. So we have condition, the volume of the balloon. Volume of balloon should be less than 50 cubic meters. If it exceeds, then balloon will burst. So this is the condition. And it is also given to us, it stopped rising at 25 kilometers. So it means that upward force, so we can draw the free body diagram. We can say the up thrust, this is equal to weight. So it simply means that up thrust, this is equal to 13.2 newtons. We have already calculated weight of equipment and balloon. And up thrust is equal to density of fluid times volume of fluid displaced times g. From here we can find out volume of fluid displaced. This will be equal to 13.2 divided by density at 25 kilometers. So we have 20, so this is 21, 22, 23, 24, 25. So 25 is about here. and we can read from the y-axis, so we can read from here, and this value is about 0.05. so we have density that is equal to 0.05. so here we have 9.81, this is value of G, and if we solve this one, we will get volume of fluid displaced that is equal to 26.9 cubic meters. And this is volume of fluid displaced, but volume of fluid displaced is equal to volume of the balloon and volume of equipment. So in this case we are assuming volume of equipment is negligible, so then simply we can say as 26.9, this one is smaller than 50 cubic meters, so it can make, so we can say yes, it can sport, so we can say yes, it can sport, it can sport, because this is volume of fluid displaced. And if we consider volume of equipment, so volume of balloon even will be smaller than this value, so that's the reason balloon will not burst and it can sport the equipment at 25 kilometers. A practical question, beautiful question. I hope this one is clear to you. This question has 4 marks. So if you have written these points, you will get 4 marks. Part C says a balloon made of a strong material will rise and eventually stop expanding. It will continue to rise until it reaches a maximum height. Explain how and why the velocity of the balloon changes from release until it reaches its maximum height. Ignore the effects of drag force. So in this case we can ignore drag forces. So we need to discuss the velocity from point of release to the maximum height. So we can take this as point of release. At this point we have mg and we have upthrust that is acting on this balloon, so we can label this as upthrust. As upthrust is greater, it means that there is net force on the balloon, so due to net force this balloon will accelerate in upward direction. As this balloon will accelerate, it means that its speed is increasing. So these points, this is how you can write down your answer, and your answer has to be in a logical order and with proper reasoning, because this question they will check your logical reasoning for this part of the question. So you can write down these points. So first you can say this point, then you can say it will accelerate, you can also say its speed is increasing. So it will accelerate. Now let's say it reaches certain height. So here we have mg, and at this certain height its volume is maximum. Now we need to understand, when the balloon is rising up, atmospheric pressure is decreasing, so balloon will expand, and density of air is also decreasing, so this balloon will finally reach a maximum volume, then it will stop expanding. And then we can take another point here. At this point this upthrust now will start decreasing, because upthrust u, this is equal to rho times v times g. Volume is constant now, we can assume it is constant, but density is decreasing. Before volume was increasing, but now volume stop expanding. As density decrease, it means upthrust will decrease. Then it will finally reach a point where upthrust is equal to mg. Upthrust is equal to mg. So at this point we can say upthrust is equal to mg. But when this balloon will further go up, now upthrust is smaller. Upthrust keep on decreasing, because when balloon is rising, density is decreasing, so it means upthrust will keep on decreasing. So at this instant net force is in downward direction, so it means this will decelerate. Balloon is rising up, acceleration is in downward direction, so this will decelerate, and finally at one point this one will stop rising. It will stop rising. So at this point balloon will stop rising. We can say it has reached the maximum height, and the velocity of the balloon finally become equal to 0, because it is downward force is, net force is acting downward direction like a ball actually. If I throw the ball in upward direction, because gravity is down, ball will reach a maximum height, it will stop, then it will start falling down. So the same is happening with the balloon. Balloon speed becomes 0, at maximum height it will stop there. So these are the points we need to write down in our answer, and this is how systematically you can write down. At this point you can, density is decreasing, you can mention here, we can say volume is maximum, and after that upthrust start to decrease. So this is greater value of upthrust, this is, and this one is smaller, and at this point mg is equal to upthrust, and here upthrust is smaller than mg, so net force is down, acceleration is also down, and now the balloon is just like in a free fall. You throw something in upward direction, it is in free fall, gravity is down, so it will decelerate, finally its speed will be equal to 0 at maximum height. So these are the points. Let me show you the answer, how you can write down your answer in a logical order. So these are the points you have to mention in your answer. So we can say when the balloon is released, upthrust greater than weight, as we mentioned here, upthrust is greater than weight, so resultant force is upward, so we have mentioned resultant force is in upward direction. Balloon accelerates upward, so velocity of balloon increases, we have mentioned here acceleration, velocity increases. After balloon is at maximum volume, mean it has reached Vmax. Upthrust decreases as height increases, density of surrounding air decreases. We have mentioned here density decreases, volume is constant now until upthrust is less than weight. So here upthrust is less than weight, so there is resultant force downwards, resultant force is downwards. Balloon then decelerate to rest, finally its velocity becomes 0. A beautiful question, very nice question. And this is also in the same way you can approach. If a skydiver jumps from a plane, so you can also explain answer in a similar way. But when skydiver jumps, actually we also talk about drag force. So here you need to understand upthrust decreases when density decreases, so just arrow has to be down. I have explained when density decreases, upthrust decreases, so this arrow has to be pointing in downward direction. Question 18 says a student carried out an experiment using a data logger to record the motion of a ball bearing as it falls through a liquid. For part A, state the conditions under which Stokes' law applies to an object moving through a fluid. Stokes' law we can apply when objects are spherical in shape, so we can say for small spheres, and we can apply when the flow is laminar flow, mean the speed is slow, laminar flow, and speed low speed. So this is when we can apply Stokes' law. F is equal to 6 pi eta r v. So these two conditions we have to write down for Stokes' law. So this is how you can write down your answer. In your answer you can say small spherical object moving at low speed and laminar flow. This question has 2 marks, so if you write down these 2 points you will get 2 marks. Part B says the graph obtained by the student is shown below. For part B1, explain the shape of the graph. So first of all we need to understand on y-axis we have displacement and on x-axis we have time. So the gradient of this graph, so we can say gradient of dt graph is representing velocity, So if you look at the gradient now, initially you can see the gradient is equal to 0. It means speed is equal to 0. And then if you look at the gradient, you can see this gradient is increasing. So it keeps on increasing until this point. And so we can say gradient is getting steeper. So if the gradient increase and gradient is representing velocity, so it means velocity is increasing. And after this point, if we draw a straight line, so we can see it's a straight line, means gradient is constant. So here we can say this gradient is constant. It means that V is also constant. So you can also simply say the ball bearing, it has reached terminal velocity. So it has reached terminal velocity. So these are the points you need to understand to answer this question. Now let me show you the answer, how you can write down your final answer. In your final answer, you can mention these points. You can write down, first of all, initially the velocity is 0, so the gradient is 0. As gradient is 0, it means velocity is 0, and so you will get 1 point. Then you can say as velocity increases, gradient changes, you will get 1 point, mean if you have mentioned about this part. And the last one, drag increases until terminal velocity when gradient becomes constant, mean here object is moving at constant velocity, so that is the terminal velocity, final constant velocity. So if you write down the third point, you will get another mark, and this question has 3 marks. Second part says the ball bearing had a diameter of 1.6 mm. The difference between the upthrust on the ball bearing and weight of the ball bearing is equal to this. Calculate the viscosity of the liquid. Assume that Stokes' law applies. So we need to apply Stokes' law for this question. So simply we can write down Stokes' law tells us that drag force is equal to 6 pi eta RV. We need to calculate viscosity. So viscosity will be equal to F drag force divided by 6 pi R times V. We have diameter, so we can find out the radius from here. That will be equal to 0.8 millimeters. Or we can say this is 0.8 times 10 to minus 3 meters. So this one is the radius. So we have value of radius, we have value of the force. Because drag force, so it is given to us that upthrust, when the ball bearing is falling down, upthrust is in upward direction, and drag force is also in upward direction, and mg is acting down. So this one is mg. So it is given to us that Ft is equal to mg minus u, mean the difference between these two forces we have, and this value is given to us. So this value is the drag force. So simply we can say this is 1.45 times 10 to minus 4 Newton. So we have value of drag force, so we can simply update here. So we have 1.45 times 10 to minus 4, and this is divided by 6 pi. Value of radius we have, that is 0.8 times 10 to minus 3 meters. We need value of V. If we have value of V, we can find out viscosity, and the V is the terminal velocity when Fd is equal to mg minus u, or simply you can say the instant when drag plus upthrust, they're equal to mg, means the mg is balanced by drag force, sum of drag force and upthrust. At that instant ball bearing is falling at terminal velocity. So this velocity we have to use is terminal velocity. So this one is the terminal velocity, and here we have displacement against time graph, and the gradient of this one is equal to velocity. We have already discussed this is a straight line, so means the gradient of this line is the velocity. And so V from here, simply we can calculate value of V. So V will be equal to, we have this point, at this point we have value of displacement, that is about 11.5, and here displacement is equal to 0, and we have value of time here, and we have value of time here. Value of time here is 1.15, and here value of time is 0.6. Then if we solve this one, we will get 20.9 centimeters per second, and we can convert this one into meters. So we will have 20.9 times 10 to minus 2 meters per second, or we can say this is 0.209 meters per second. So simply we can write on here now 0.209, and if we solve this one, we will get value of viscosity, that will be equal to 0.04 0.60 Pascal second. So this is our final answer. This is how you can calculate. Main concept is simply you need to understand F is equal to 6 pi eta r v. Then you need to identify this is the terminal velocity, and you need to understand this value is the drag force because the ball bearing is falling at constant velocity, and then you can figure out viscosity. Third part says the student heated the liquid and repeated the experiment. The ball bearing took a less time to fall a given distance in the liquid when the liquid was at a higher temperature. Explain why. Assume the density of the liquid is constant. Similar question based on the same concept you can also find in May-June 2023 section 1 paper 1. You can find the same type of question. So how we can answer this question? In order to answer this question, it is given to us density is constant, so it means that upthrust rho Vg also remain constant because density is constant, volume of fluid displaced is constant because volume of object is constant, T is constant, so it means this also remain constant. And drag force Ft, this is equal to 6 pi eta r v. In this case, it is given to us that temperature increases. As temperature increases, viscosity will go down. As temperature increases, viscosity of the fluid will go down. Mean fluid will be less viscous. As fluid is less viscous, it means drag force will go down. So we can say as viscosity will decrease, Fd also will decrease. Radius, size of the object is constant, and if this drag force remains constant, then velocity has to increase. So why this drag force has to remain constant? When object, the ball bearing, very important point, when ball bearing reaches terminal velocity, this weight of the ball bearing, this is balanced by the upthrust and this is balanced by the drag force. So this is balanced by drag force. So from here we can say mg, this is equal to u plus ft. So when it is falling at terminal velocity, as this remain constant, this also constant, this also has to remain constant. So this is the logic why drag force has to be constant, because most of you will be struggling with this one, why drag force is constant. So drag force is constant, so if viscosity go down, this quantity is constant, so the velocity has to increase. So as velocity increase, so the distance covered, the same distance covered, so we can say as distance is equal to v times t. So any given distance, if the speed is greater, time taken to cover that distance will be shorter. So that's reason it take less time to cover a given distance. So we are talking when it is falling at terminal velocity. So these are the points you need to write down in your answer. So the first point we can say at a higher temperature, so you can say higher temperature, viscosity will go down. So you can mention this point. So this can be 1 point. Then we can also talk about this point and about this one. We can talk about forces. We can also say upthrust will remain constant, and then we can also say Ft also has to be constant when the ball bearing is falling at constant velocity. Then we can say as viscosity go down, so the velocity has to increase, speed has to increase. So as speed has increased, so the time taken to cover the same distance will be shorter. So these are the points you need to include in your answer. You can also check this paper and you can look at the question again in section 1. I hope this one is clear to you. Let me show you the answer, how you can write down your final answer. In your answer, you can mention these points. If you write on this 1 point, you will get 1 mark. This question has total 4 marks. This is the second point. You can say R is constant, F is equal to this. Drag force is less at a given speed. Means at any given speed, when the temperature is low and when temperature is higher, drag force will be lower because speed is lower, but terminal velocity will be greater. So drag force at terminal velocity is unchanged, mean it is constant. Terminal velocity is greater than before, so the ball bearing takes less time to fall the given distance. So I hope this is clear to you. At a given speed, mean if we take same speed when temperature is low and we take the same speed when temperature is higher, as at higher temperature viscosity has decreased, so this force will decrease. So this is one way you can explain. Another way to explain is at terminal speed, as I explained you here, drag force is unchanged, means the drag force when the object is falling at terminal speed at higher temperature, and drag force when the object is falling at terminal speed at low temperature, value of drag force is the same because upthrust is the same. If you have any questions, please leave your questions in comments and I will try to answer as soon as possible. If you need more help and you want to support this work, please join Patreon, and also on Patreon you can find more resources.